Hey there, welcome back. In this video, we're going to go deeper into the different types of things you can do with Zoom Data's charts and dashboards. We're going to build this section around a couple hypothetical scenarios to give you a little bit of insight into how these different functionalities will work toward a real-life project or use case. So what I'm going to do now is jump into the Zoom Data instance I have set up, and I cleared the last chart that was here, so it's empty. And I'm going to think to myself and say, what if I were the airport manager or a technical resource working for the airport manager at Dallas-Fort Worth? And the goal here was that the airport manager wanted an LCD, a heads-up display that showed the average departure delay for that day so far, or for the last 24 hours, so that the people working at that office could use that for operational purposes. How would you build that out in Zoom Data? Well, let's get started. So let's create a new chart or dashboard, and we can do that by clicking that blue New button. Or alternatively, another way we can create a new chart or dashboard is by clicking this hamburger menu, clicking Data Sources, clicking the data source we want, which in this case is the FAA Flight Delays CSV. And once we click that, we get another identical menu of charts that we can build using this data source. So these are two ways to access the same functionality. So in this case, we're going to start with a KPI chart. And this is a very simple chart style. All it does is it displays one key performance indicator or metric, and you can adjust the color of it. You can also compare it to another metric. In our case, what we want to show is the average departure delay of planes leaving Dallas-Fort Worth in the last 24 hours. So let's first change this metric to departure delay. Let's make sure it's the average. Cool. So the average departure delay is 12 minutes 20. That's, however, the average for every airport in the data set. It's not for just Dallas-Fort Worth. How do we limit this to just Dallas-Fort Worth then? Well, the answer is a filter. So in our left rail, we can click this filters pane, and it'll help us add a new filter. You might notice that there's already one filter selected. It's called Control from Time Bar. That's because the time bar here is actually a filter that's controlled with this widget here that lets you select the time for which the data is filtered and streamed in. We're going to, in addition to that, add a new filter on Origin Airport. Make sure it's on Include and not Exclude. So you can choose to include or exclude. And we're going to include Dallas-Fort Worth. Once we apply that, the data will update and shows that the average departure delay for Dallas-Fort Worth, rather than 12:20, is 12.42 minutes. So it's just a little bit more delayed than average, but it's very close to the middle of the pack. Great. So now we have the average departure delay, and we have it specifically for Dallas-Fort Worth. What we haven't done yet is that rolling 24-hour time frame. And to do that, let's use the time bar. Let's pick a day. What I'm going to pick is June 1st. So you can do this by clicking each of the side tabs on the time bar. And you will see that the central section will actually, the ticks will change. It used to be quarters, now it's months. We zoom into the month of June, and it'll turn into days. There we go, June 3rd, June 4th. One thing to note is that this isn't the only way to try change your time period. There are two other ways. One is if you click this or this, it'll let you change your time range. So you can just say, oh, I want June 3rd, 12 a.m. to June 4th, 12 a.m. Okay, yeah, that's 24 hours. You can also change your starting time by clicking this green starting time and change it that way. and your ending time by clicking the green ending time and changing it here. So there are 3 ways for you to change the time in the time bar. Great. So now we've done exactly what we wanted. This is actually 48 hours, so let's bring it down to 24. Great. So for June 3rd, for that 24-hour period, the average departure delay was 7 minutes 38. And so that's kind of interesting. It seems like June 3rd trends lower than the yearly average. Now, one other thing we can do with this data source with the time bar is we can do data playback. So if we hit play and change this time rate from 1 minute per second to 1 hour per second, you'll see with each second, more data gets streamed in to the data that's being looked at, and the departure delay starts to change. One thing you might notice, though, as this is happening, is that the start date isn't changing. More data is getting added in as time goes on, but it's cumulative. The start date is fixed. You could say it's pinned. That's because this pin start time button here is checked. Now, if we wanted just 24 hours and we wanted that 24 hours to roll forward with our playback, what we could do is we can unpin the start time. And then when we hit play, both the start and end times will update. And so then we have a rolling window that way. This can be really useful for seeing how trends affected data in real time. And if you have a data source that supports real-time streaming, you don't even need to use playback. You can actually just cover the max available range or use one of the preset rolling ranges, like rolling 90 days, rolling 7 days, and your data will update in real time. And that can be very useful for operations settings. So hopefully this gives you some insight into one of the potential use cases for a Zoom data chart or dashboard. Moving forward, I want to show you some ways to change chart styles and some ways to change chart styles within chart styles, so chart sub-styles. So I've shown you how to create a new chart in 2 different ways, but what if you wanted to keep all the information about this chart, that filter on Dallas-Fort Worth, the time bar settings, the fact that it's sorting on the metric is departure delay, but you wanted the chart style to be different? This can happen often when you create a pie chart and you put a lot of time into it and you develop some great filters and you're like, wait a second, this pie chart would be so much better as a bar chart. Well, luckily you don't have to remake your chart. You can use this chart style button here on the left rail. And if you click that, you'll see all the different chart styles, and you can also even sort by different substyles. And we could click bars, and what that gives us is a bar chart. So you'll notice that the filter on Dallas-Fort Worth is still here, and the metric departure delay is still the same. Now, what if we were the FAA and we wanted to compare the performance of these 5 airports monthly for each month? And we didn't want to do it using a line chart. We wanted to do it using, let's say, clustered bars. Does Zoom data support that? Well, let's find out. So the first thing we want to do is get rid of this Dallas-Fort Worth filter because we want to look at all the different airports. So what we're going to do is click expand here on the top where it shows the filters listed, and it'll show us our filters. We can hit this red button to get rid of the Dallas-Fort Worth filter. And once we do, the other airports will flow in very nicely. All right. Now what we want is clustered bars. How do we get that? Because I don't know if you guys noticed, but when you went to chart styles, there's no clustered bar chart. However, when you're on the bar chart, if you go down to settings, you can change some settings. You can make it horizontal, you can make it vertical, and you can also change the subgroup style. And this will let you create a clustered bar chart. So when we click that, the colors change, and also there's now a subgroup picker that wasn't there before. And this will let us do what is essentially a double group by. First, we're going to group by month so that we have one set of bars for each month. And then within that, we're going to group by origin airport so that within each month, we're comparing all the different origin airports by their delays. So let's get that happening. To group by month, we can actually go into the attribute picker and pick a time. And that'll create a time granularity picker. So now we have days. We don't want days. We also don't want weeks. We want months. And then within each month, we want our subgroup to be origin airport. Wonderful. So now you see, for example, for March, you can see O'Hare has a lot of delays. And then for November, you can see LAX is doing really well. However, you might have noticed that these months aren't in order. So if you guys have watched the previous video about sorting and limiting, you might know what the problem here is. It's that the sort metric hasn't updated. The sort metric is still set to which month has the highest number of flights. So to make this in chronological order, we want to set the sort metric to scheduled departure and chronological. You can also set it to reverse chronological, which can be useful if you want to see the newest data first, but we kind of want to look at it historically. So let's do that. And now we can see January, February, March, May, July, that's all in order. And you can see a little bit of an annual trend, the same one we saw in that line chart in the last video. A big peak in the summer, a fall in the winter, and you can see that all around the year, some airports like O'Hare has lots of problems in the winter, not as many problems in the spring. Dallas-Fort Worth has more delays in the spring. So this type of chart can lead you to some interesting conclusions. So if you wanted to display that data in a different way, the same data, but instead of comparing between bars in a chart, instead show the total average delay for all of these airports in that month, but show each individual airport's contribution to that average, you can instead use this stacked bar style. And looking at that, you will see it'll actually just stack all these bars on top of each other so that you can see that, for example, in June, there was a lot of delays, and the major contributor to those high delays was O'Hare. And you can also roll over these guys for more information. Now, one other type of chart substyle you can use is the 100% stack bar chart. Same exact thing, except that now these bars are stretched to fill the whole screen, giving a greater emphasis on the proportion that each subcategory of each bar has. One thing you might have noticed is that these colors aren't 100% consistent, and to make that so, we can use origin airport. We want to sort it by origin airport alphabetical, and that should fix that. Lovely. So now you can see kind of almost like a ribbon chart how this contribution changes over the year. The last chart style I want to show you guys in this video is one that actually lets us use more than one metric. We're going to look at the scatter plot, which is one of the oldest and most powerful tools for correlating two different metrics. So what we're going to do here is we're going to set our group to origin airport, and then we're going to set our x-axis to departure delay. So now we can see which airports have the most delays in terms of departure on the x-axis. And then on our y-axis, what we're actually going to do is put average arrival delay, because the theory here is there should be a correlation between departure delay and arrival delay, because if a plane departs late, it should also arrive late. Let's see if that's true. Well, looks like it is. Looks like there is a pretty clear correlation here. Now, one thing I don't like about how Zoom Data set up this plot right now for us is that the axes aren't even. They start at numbers that aren't 0, and they've been used to stretch out these points over the whole range of the screen, which is wonderful for displaying data in a large way. However, if we want to really visually see the correlation, we're going to want to make both the x and y axes the same. And to do that, we're going to click this rulers button here on the left rail. Once we do that, we can enable and disable grid lines. We can change the axes, start, end, and steps. So if we want more of these markers here, we can use a logarithmic scale if we really wanted to. And we can also add reference lines. Now, mind you, not lines of best fit, but for example, if there's a threshold for delay that you don't want airports exceeding, you can put that in your charts. Now what I'm going to do next is set these grid lines so that both the x-axis and y-axis rulers go from 0 to 18. I'm also going to disable the auto in case we change the data and the grid lines change. Interesting. While less of the screen space is covered by the points and there's more empty white space, you can see that in general, while there are pretty high departure delays, arrival delays actually are lower on average than departure delays. So if your average O'Hare plane departed 16 minutes late, it arrived 8 minutes late, which is less of a delay. So it looks like in a lot of cases, pilots are making up that delayed time in the air, or maybe they've accounted for some amount of delay in their flight time estimates. So that's kind of an interesting insight. Also, we can see that LAX generally has the lowest delays, both in departure and arrival, and O'Hare has the highest delays. So if you've ever flown in Chicago O'Hare and you've been delayed, now you know you're not alone. It's statistically a fact. One other thing to note is that the size of these bubbles is also representative of data. We could set it, of course, to be constant, but you can also set it to represent a metric like it was before with number of flights. You can see that LAX has a much larger number of flights, 26,000, than IAD, 10,000. However, one thing you should keep note of is that this bubble size is not absolute, it's relative. And so what that means is if only these two were here, O'Hare and LAX, even if they have very, very similar numbers of flights, which they do, 26,400 versus 26,300, one will be very small and one will be very large because relative to each other, one is smaller than the other. So that's something to bear in mind when you're using the bubble size picker in the scatter plot. And let me highlight that for you by getting rid of these three middle points so you can see that in action. So how we would do that is actually we can either go into filters and do the same airport filter we did before, origin airport, and only include LAX and ORD, or we could say exclude the ones that aren't LAX and ORD, and you can see suddenly O'Hare is really small even though their numbers are very similar. Or as a quick and easy alternative, another thing we can do is clicking on any point will bring up the radial menu, which has a lot of different options, and one of them is remove. And when you do that, it will automatically create a filter to remove that point from your data set. So now if we go into filters, we're going to see exclude Dallas-Fort Worth. And once we do this to all the other three, this filter will be identical to the one we just created manually before. So now you know about how to remove points that you don't like from your data set, for example, outliers. You can use a filter, or you can use the remove function in the radial menu. All right, fantastic. So here we've covered a hypothetical for when you would use Zoom data dashboards in an operational setting. We've looked at different substyles for charts, for example, clustered and stacked bars. We've explored filters. We've explored the time bar. We've explored correlating multiple metrics and changing rulers. And we've begun to see the different functions that are available in the radial menu. One more thing I want to show you guys before we drop back out of this demo is now that we have this scatter plot, it's very nice and we might want to use it later. So let's save it. So to save, you click the Save button up in the top right. And when you do, you get a bunch of options. You can give it a name. In our case, we're going to call it flight delay scatter plot. Great, we can give it a description. I won't do that. This remember time positions check mark is helpful if you've set your time bar to a specific time and you want it to always start on that time. And then this share checkbox will let you share it with all the different users in your Zoom Data account. So if you're collaborating on a chart with other people who have different logins than you can click this and you can choose whether they can view only or view and edit, and then they'll all be able to see it. It'll show up in that shared with me section in the home screen. Now, I'm not going to check that right now, but it's good to know. So let's save. Once it saves, it'll give us this nice green banner. And when we go back home, we'll be able to see it right here and open it back up. Fantastic. One last thing, I want to give you a quick refresher on filters. So essentially, filters will use conditions to limit the data that's being charted. If you're filtering on an attribute like we did, you can include and exclude. If you're filtering on a metric, you can use all of these operators, greater than, less than, equal, not equal to, greater than or equal to, less than or equal to, as well as a range. So between delays for between 15 and 20 minutes. And for times, like you saw with the time bar, you can use time ranges in addition to the time bar. The time bar is technically a filter. It's the control from time bar filter. It's just a really easy to use one. And one thing to know is using the star button in the top right, you can actually save your sets of filters and reuse them or share them with other people who are on that Zoom Data account on that instance. And we're going to actually save a filter in the next video, which covers dashboarding. And that's all for this video, and I will see you in the next one. Goodbye.